It seems we're live. All right. Oh, it looks like it started right when I was taking a drink. So that's a perfect start, right? Happy Wednesday morning now. Uh, it's a tough morning this morning. I think I spent up way too late last night looking at machine learning things. But it was fun as well. Good morning, Felix. I guess it's morning for me. You're in Germany, right? So that's the afternoon. It's the afternoon. Awesome. Well, thank you for joining in. I've got myself some tea here to help wake myself up. But it's going to be a continuation of Rust stuff this morning. All right, which reminds me, I have to figure out where we were again. So okay, so in the README, I think I forgot to update where we were. So, looks like we were in chapter 6. Something. Let's go find out. Second edition, chapter. Probably just 6.1 defining an enum. Right, because I was getting confused about like when to use enums, and I think that's mostly because enums, like I don't think I've ever worked with enums before. All right, so we went through IPv6 stuff. I don't think I read this one yet. Sorry about that. Luckily, I muted it before I sneezed. Did I read this one yet? Let's see. I remember it was a huge long one about IP addresses, and that looks like it was this one. So I think we got through these enums. So I believe we're here. So that's still 6.1. I'm actually going to save and commit and send this up because that's where we were. Where we stopped. And that way, if anybody is following these commits, they can get back easily. I'm curious if I... Okay, yeah, so code yells at me unless I open it in the appropriate folder. Otherwise, it won't be able to like provide any assistance to me. So I'll just close this. And we'll get going. All right, so the option enum and its advantages over null values. In the previous section, we looked at how the IP address enum let us use Rust's type system to encode more information than just data into our program. This section explores a case study of option, which is another enum defined by the standard library. The option type is used in many places because it encodes the very common scenario in which a value could be something or it could be nothing. Expressing this concept in terms of the type system means the compiler can check that you've handled all the cases you should be handling, which can prevent bugs that are extremely common in other programming languages. Programming language design is often thought of in terms of which features you include, but the features you exclude are important too. Rust doesn't have the null feature that many other languages have. Null is a value that means there is no value there. In languages with null, variables can always be in one of two states, null or not null. Yes, that is very true. In the case of JavaScript, it could be 3, but we're not talking about JavaScript here. In null references, the billion-dollar mistake, Tony Hoare, I don't know how to pronounce that last name, the inventor of null, has this to say: I call it my billion-dollar mistake. At that time, I was designing the first comprehensive type system for references in an object-oriented language. My goal was to ensure that all use of references should be absolutely safe, with checking performed automatically by the compiler. But I couldn't resist the temptation to put in a null reference, simply because it was so easy to implement. This has led to innumerable errors, vulnerabilities, and system crashes, which have probably caused $1 billion of pain and damage in the last 40 years. I don't know, with some of the hacks that have happened because of various pointer problems, maybe even more than that these days. The problem with null values is that if you try to actually use a value that's null as if it's not a null value, you'll get an error of some kind. Because this null or not null property is pervasive, it's extremely easy to make this kind of error. However, the concept that null is trying to express is still a useful one. A null is a value that is currently invalid or absent for some reason. Like, for example, it hasn't been set yet, and we're sort of waiting for it to be there. And so maybe we'll check. When you're not null, then we'll start doing something. The problem isn't with the actual concept, but with the particular implementation. As such, Rust does not have nulls, but it does have an enum that can encode the concept of a value being present or absent. This enum is option T and is defined by the standard library as follows. So enum option T, so that's going to be the type, because we saw this, what did you call it, Felix? It was turbo something fish syntax. Then some, that's type, or none at all. The option T enum is so useful that it's even included in the prelude. You don't need to bring it into scope explicitly. In addition, so are its variants. You can use some and num directly without prefixing them with option : Option and then the type is still just a regular enum, and some, T, and none are still variants of option type. The T syntax is a feature of Rust we haven't talked about yet. It's a generic type parameter, and we'll cover generics in more detail in Chapter 10. For now, all you need to know is that T means some variant of the option enum can hold one piece of data of any type. Here are some examples of using option values to hold number types and string types. Okay, so let some number equals sum of 5. Let some number equals sum a string. Wait, really? Oh, okay, I read that as some number. I'm like, no, that's wrong. Some string equals sum a string. Let absent number option I32 equals none. So does that mean that this can be changed? I sort of wanna try this. So let's come into Chapter 6, cargo create binary option type. Oh, it's new, isn't it? Okay, so we'll go into option type and open up code here. Okay, so here, what I want to do is create a, I guess like the option already exists, right? Do we have to pull it in, or is it already available to us? I guess it's still just trying to explain to us what's really going on, but I could actually maybe implement this myself. It's defined by standard library, so let's go take a look at that. Standard option. The option type, see module level documentation for more. No variant, some t, some value t. So let x option u32 equals sum 2. Okay, so if I could say like, okay, x is going to be option 32 equals. I still don't fully understand what sum means here. Like I think, do they have it down here? Option is auto imported like vector or string. Ooh, so I can just use it and it's there. So let x tell it it's an option and then what type it's going to be. Does sum like auto cast, is that like into, or option sum is also auto imported, so it's just available to me. Oh look, sum. Returns true if the, wait, that's is a sum value. Oh, that's just self-referential now. I guess is sum doing something to it? Because like I'm using parentheses with it. It's a capital number. Is sum an enum or is sum a struct of some kind? So sum 10.toString. So that's like converting it. Convert an option string into an option usize, preserving the original. The map method. Okay, so it's not really describing sum. Maybe the book will like describe it a little bit more, but I might be able to sort of play with this now. So like let x, I'm gonna say this is type. You can also say let x equals option sum 5, but it's shorter to just write just sum 5. And option is just enum, yeah. And here's where like I am going to explicitly cast and say like, okay, this is an option, this is an enum, but the type that the enum is going to be a like u32, let's say. And then I can say sum and like pass in 32, but didn't. Oh yeah, and then it's just none. So I can do that, and if I print line, can I print line x right here? No, it doesn't implement the standard implement display. So let's try that. Let's see if this works. I'm also curious, can I get the, I forget how to like set the terminal in here. Oh, toggle integrated terminal. Oh, and I can make this be over on the right too. Nice. Okay, I'm gonna say cargo run. None, perfect. Okay, so then if I now later on say x equals sum 32, do I need to say like it's mutable? Yes, probably. Can assign twice to immutable, so then I'll do mute. Value assigned to x is never read. What are you talking about? Oh, this value assigned to x is never read. That's fine. So we run this, and we get that it's sum 32. Oh, wait, that wasn't what I wanted. I guess assign is like destroying it and like creating it something else. I was hoping that, well, okay, it was not the hoping. I was assuming things and then proving that I don't know what the assumption is. So what I want to know is if I have an absent number, can I later on turn this into this thing, but have it limit me what I can turn it into because I'm just telling it, you're this option that can only be an I32. Maybe it'll actually tell us that. If we use none rather than some, we need to tell rest what type of option T we have, because a compiler can't infer the type from that sum variant we'll hold by looking at a none value. When we have a sum value, we know that a value is present and the value is held within the sum. When we have a none value, in some sense, it means the same thing as null. We don't have a valid value. So why is having option T any better than having null? In short, because option T and T, where T can be any type, are different types, the compiler won't let us use an option T value as if it was definitely a valid value. For example, this code won't compile because it's trying to add an I8 to an option I8. So X is I8 and Y is option I8. And yeah, so that it won't add us together because like these are two completely different types. If we run this code, we get an error message like this. So the trait is bound. It's not satisfied, so there's no implementation for I8 plus like this other number. Intense. In effect, this error message means that Rust doesn't understand how to add an I8 and an option I8 because they're different types. When we have a value like a type I8 in Rust, the compiler will ensure that we always have a valid value. We can proceed confidently without having to check for null before using that value. Only when we have an option I8 or whatever type of value we're working with do we have to worry about the possibility of not having a value, or about possibly not having a value. And the compiler will make sure we handle that case before using that value. Wait, does that mean that I can add, so like if I have sum 32 like that, so then we have a sum 32 in here. Print line this. So then if I have another one, so like let y option u32 equals sum 1. I don't need that mute anymore. Can I now do x plus y here? Binary operation plus cannot be applied to standard operation option U32. An implementation of standard ops add might be missing. Okay, so it doesn't really know these because they're not number types. There are some custom types that I made, and I would need to teach it, like tell it how adds can happen. And I can't remember. Sort of mark that. I guess it's not really like accessing and like the content of an enum because it's not a structure like that. It's more of that's just what it is. Okay, so in other words, you have to convert an option t to a t before you can perform t operations with it. So yes, like the exact opposite of what I tried. Generally, this helps catch one of the most common issues with null, assuming that something isn't null when it actually is. Not having to worry about missing an assumption of not having a null value helps you to be more confident in your code. In order to have a value that can possibly be null, you must explicitly opt in by making the type of that value option t. Then, when you use that value, you are required to explicitly handle the case when the value is null. Everywhere that a value has a type that isn't an option t, you can safely assume that the value isn't null. This was a deliberate design decision for Rust to limit null's pervasiveness and increase the safety of Rust code. I think this might be one of the ones where it's gonna like change how I think about the code the most. Because like right now, I'm just so used to in other languages going in and just saying, well, I better do an if to check to see if it exists, and then I can do everything. And then you just litter ifs everywhere in your code, checking for existence. And I could see this being like a really interesting way of now not needing that is it's definitely going to be sort of like get something to get used to. But I think it's going to be pretty awesome. So how do you get the t value out of a sum variant when you have a value of type option t? So you can use that value. The option t enum has a large number of methods that are useful in a variety of situations. You can check them out in its documentation. Becoming familiar with the methods on option t will be extremely useful in your journey with Rust. Okay, so I think that's what we looked at before, but let's close these. So enum, standard option, none or some. The option type, okay, so variance, no value. Sum is some value t. So there's methods here. So implement t, return true if the option is a sum value. This feels like implement t, option t. Oh yeah, okay, the implementation. So like these are the implementations. So is sum, returns true if option is some value. Is none, returns it if it's a none value. So that's where I guess I would put my if statement to check this. Oh, is this where it's like that if let? Because if it exists, let x equals whatever that thing is. Is that what we're sort of like moving towards? As reference, converts from option t to option reference t. Preserving the original, the map method takes the argument value, consuming the original. So this technique uses asref to first take. Interesting. As mute converts option T to reference mute T. Expect unwraps an option yielding the content of a sum. Panics the value is a none. So x dot expect the world is ending if x is like none. Unwrap moves the value v out of the option T if it is in some v. In general, because this function may panic, its use is discouraged. Instead, prefer to use pattern matching and handle the none case explicitly. You can use the dot unwrap on the option to take out the inner value, but in none case, unwrap will crash the program. Yeah, so that's what I'm seeing here. And it's also saying like it's discouraged, so they don't want you to do it. They just allow you to do it. So it looks like, okay, yeah, so I can do x unwrap and air. Okay, so I could do that. Unwrap or returns the contained value or a default. Oh, that's nice. Arguments passed to unwrap or are eagerly evaluated. If you are passing in the result of a function call, it is recommended to use unwrap or else, which is lazily evaluated. Unwrap is common for prototyping. For release code, only do unwrap if you are sure that the value can't be none. Oh, interesting. So like if you just want to like make it really quick, you just use unwrap because it's super quick, but then do it properly otherwise. Unwrap or else returns the contained value or computes it from a closure. Interesting. Map maps an option T to an option U. Oh, so it like convert, like changes it. Map or else. Okay, or. Oh, interesting. Like then there's actually a result. Okay, or else. Iter returns an iterator over the possible contained value. Iter mutable. And returns none if the option is none, otherwise returns option B. And then filter returns none if the option is none, otherwise calls predicate with a wrapped value and returns some T if predicate returns true. Okay. We have or else. There's a lot of methods on here. Get or insert. Inserts V into the option if it is none. Then returns a mutable reference to the contained value. Ooh, I think that's what I was getting at. Get or insert. Get or insert with. So mute self T. Insert a value computed from F. Okay. I kind of want to try this get or insert with that example that I was attempting to do, but didn't know what I was doing. So if I say let option U32, and this is going to be none. Now, none doesn't exist. I can't do the math. But I can maybe say X, what is it, get or insert, and pass it in like 64. Fail to resolve use of undeclared type or module X. Wait, it's right there. Is it not colon? Is it just dot? Oh, cannot borrow. So hold on. So what is it trying to do? I should actually look at the example code here. Okay, so let mute x equals none. Let y equals mute u32 x dot get or insert 5. Assert equality of y and reference to 5. I thought they were going to use option in this example, but I didn't see that. Unless I have gone way past where the options were. All right, I'm going to leave that alone for right now. That sounded like it was going to be cool, but it looks like that's only on none, which is different than storing none inside of an option and then dealing with it, I believe. Takes the value out of an option, leaving a none in its place. So they keep on doing this, where it's let mute x equals sum2. Is sum returning an option? Let mute x option 32 equals none. X dot take. Now, if I attempt to take when there's a none, yeah, it's just none is extracted. And then none, this becomes none there. All right, I think there's going to be a lot of fun things we can do with this. Oh, and then there's the traits. All right, let's go back to the book. In general, in order to use an option t value, we want to have code that will handle each variant. We want some code that will run only when we have a sum t value, and this code is allowed to use the inner t. We want some other code to run if we have a none value, and that code doesn't have a t value available. The match expression is a control flow construct that does just this when used with enums. It'll run different code depending upon which variant of the enum it has, and that code can use the data inside the matching value. You did this in the last section, x equals game system NES. Same with x equals option sum 5. Oh, okay. So that's what I was doing. I think it's just going to be practice with enums and sort of playing around with it. And then maybe not always programming when I'm really tired. Okay. I guess match is also a way we're going to take things out of it. So let's move on to match. The match control flow operator. Rust has an extremely powerful control flow operator called match that allows us to compare a value against a series of patterns and then execute code based upon which pattern matches. Patterns can be made up of literal values, variable names, wildcards, and many other things. Chapter 18 covers all the different kinds of patterns and what they do. The power of match comes from the expressiveness of the patterns, and the compiler checks that all possible cases are handled. Think of a match expression kind of like a coin sorting machine. Coins slide down a track with various size holds along it, and each coin falls through the first hold and counters that it fits into. In the same way, values go through each pattern in a match, and if the first pattern the value fits, the value will fall into the associated code block to be used during execution. Because we just mentioned coins, let's use them as an example using match. We can write a function that can take an unknown United States coin and, in a similar way as the counting machine, determine which coin it is and return its value in cents, as shown here in listing 6.3. Okay, so we're going to have an enum coin, which can either be a penny, nickel, dime, or quarter. And so we're not going to say it can be none. Like, it has to be something. Then we're going to have a function, value in cents, that takes in a coin of type coin and responds with the unsigned 32-digit integer of how much value it is. And we're just going to do match coin. And so if coin is penny, it's returning 1. Okay, I remember doing this way back in chapter like 2 or 3. Let's implement this one. This will be good to sort of have some good code written down about enums and actually using them. Okay, so I also want to quit. What did I call this option type? I could leave option type in here and just work with this. Okay, so none of this stuff was really mattering to me. Let's do this. Let coin, no, it's enum coin. Enum coin, and then we're gonna have just all the coins. So what is it? Penny, nickel, dime, quarter. And did we have to, one thing I noticed is that we didn't like create any instances of it. Oh, and he used capital letters for these. And I think what I can then, are these themselves going to be types? Or is it more of like coin equals like this? Oh, wasn't it like I could have like penny and then tell it like it's a string. Because right now it's, so how would we implement this and like actually create our coin? Because we want this. I would potentially do something like let x equals, and then it's going to be, I already forgot how to spin off an instance. Let's go back one chapter and take a look at setting that. Okay, yeah, so it's just saying like which one it is. Oh, right, because we wouldn't really have to care about like its actual data, so it would be the name of the enum : the type. So let x equals coin : penny, like that. So my penny. And maybe we could do another one. Let shiny nickel equals coin nickel. Then we can have that function which will I guess I'll just do a print line and have it be my coin is worth cents. And it's going to be calling the function get coin value and passing in my penny. And I can duplicate this with shiny nickel. But down here, I need to... You're not going to yell at me? I'm surprised that this is not yelling at me for not existing. Okay, so function... they're called enum variants. A coin can only be in one currency at a time, not multiple. Oh, like, so this can, like, this is a variant of coin. This is a variant of coin. I cannot have a coin like this variable cannot have like be a penny and a nickel. It's just going to be a coin, but the variant could be penny of that coin. Okay, so get coin value. This is going to take a coin of type coin. Oh, this needs to be outside, doesn't it? So it's accessible everywhere. Okay, it's going to return an unsigned 32. And we're going to match coin. And if coin is type penny, was it fat arrow? I think it was fat arrow. And this is going to be like a 1, return 1. And if coin is nickel, return 5. And no semicolon because we want to auto return this. We save this. I'm still not getting any feedback from my editor anymore. I don't know why. Let's run this and see what it says. Use of undeclared type or module coin. Well, isn't it determined right there? And same problem there. Could not compile option type. Failed use of undeclared type. Okay. Right, so it doesn't like this part right here. Capital C. Does it match this? Well, I thought like it's taken in coin as coin. Or maybe, oh, is this coin like if it's this type of coin? Like that? My computer seems very slow today. Patterns, diamond, quarter not covered. Ooh, yeah, so it won't let me in it. So that was correct. So thank you for the capital C. So, hey. My code just froze. Am I still streaming successfully? No drop frames. Everything seems to be here. Oh, we're back. Oh, that's weird. Okay, so it needs me to now cover coin, dime, and that's 10, and coin quarter is 25. So this should be just fine. Warning, variant is never constructed dime, and variant is never constructed quarter. Okay, so it's basically saying, hey, look, you can make these. Don't tell me you can make these if you're never actually going to make these. But it is sort of nice to be able to see, like, okay, there's a way to sort of like match out and potentially extract, well, some kind of meaning and data or information from coin. So that's nice. My code is frozen again, so I'm just going to go back to the book. Or no, okay. Yeah, my computer is definitely acting a little bit weird, which is strange because I turned it off overnight and booted it up this morning. Okay, where was I? We just did this. All right, let's break down the match in the value in sense function. First, we list the match keyword followed by an expression, which in this case is the value coin. This seems very similar to an expression used with if, but there's a big difference. With if, the expression needs to return a Boolean value. Here, it can be any type. The value of coin in this example is the coin enum that we defined in listing 6.3. Next are the match arms. An arm has two parts, a pattern and some code. Right, so I remember the arms from like before when we used this. You could rewrite the Fahrenheit Celsius thing with enums just as an idea. Ooh, yeah, so maybe when we reach this, I will go back and do that. In fact, that's a good enough idea that I want to write it into the README. So currently at, we can do end of chapter plan, rewrite F to C converter using enums. Okay. Also, I went down too far. Where was, okay, here. All right, so we have the match arms, we did that. When the match expression executes, it compares the resulting value against the pattern of each arm in order. If a pattern matches the value, the code associated with that pattern is executed. If that pattern doesn't match the value, execution continues to the next arm, much like a coin sorting machine. We can have as many arms as we need. In listing 6.3, our match has 4 arms. The code associated with each arm is an expression, and the resulting value of the expression in the matching arm is the value that gets returned for the entire match expression. Curly brackets typically aren't used if the match arm is short, such as in listing 6.3, where each arm just returns a value. If you want to run multiple lines of code in a match arm, you can use curly brackets. For example, the following code will print out lucky penny every time the method was called with coin penny, but it would still return the last value of the block 1. Yeah, I remember, I think we did this in one of those examples. 10 minutes left, but let's go through this last section. Patterns that bind to values. Another useful feature of match arms is that they can bind to parts of the values that match the pattern. This is how we can extract values out of enum variants. As an example, let's change one of our enum variants to hold data inside it. From 1999 through 2008, the United States minted quarters with different designs for each of the 50 states on one side. No other coins got state designs, so only quarters have this extra value. We can add this information to our enum by changing the quarter variant to include a US state value stored inside it, which we've done here in listing 6.4. Okay, so enum US state, oh man, that would be a large enum. And then enum coin. Okay, so penny, nickel, dime, quarter, which then takes in the enum US state. Okay, so that's interesting. Let's try adding that in here. So if we have quarter and then we add in like US So it feels interesting that this is Pascal case here, US state, instead of snake case. Also, does it matter what order I do this in? Can I do US state, and then we'll just do Colorado, because that's where I am. Okay, so I have my penny, coin penny this, shiny nickel is this one, and now I can do let we can do maybe this one, which is let state equals US state Colorado, and then let quarter equals coin quarter, and then I think I pass into this. I can't remember if it's curly brackets or this. I didn't actually look, but I'm just going to try it and see what the error is. I want to pass in the state. And then I want to print line. Actually, I just want to repeat this. My quarter is worth X cents, and we're going to pass it in our quarter, which now means if we get quarter, we're not just going to return 25, which we could though. We might want to do something like because now I can delve inside here and get Colorado. So can I just do match coin quarter? Not exactly sure how to delve in, so let's continue reading for a second. Let's imagine that a friend of ours is trying to collect all 50 state quarters. While we sort our loose change by coin type, we'll also call out the name of the state associated with each quarter, so if it's one our friend doesn't have, they can add it to their collection. In the match expression for this code, we add a variable called state to the pattern. That matches values of the variant coin quarter. When a coin quarter matches the state variable, we'll bind to the value of the quarter state. Then we can use state in the code for that arm like so. Okay, so state, just like whatever was in the quarter is now state. So I can now some quarter from. So I can do quarter state like that. And now when I run this, I could just use it. So I don't have to do like another match. I could do a print line and go, you got state state. But then we're going to return 25. Let's see if this works. Waiting, waiting, waiting. Okay, US state cannot be formatted with a default formatter. Try using question mark, colon question mark. Instead, if you're using format string, okay, so, oh. Okay, let's try that. Oh, right, we need to have the derive debug thing. But luckily, it tells us exactly what to do. Oh, I need to use Control Shift C to copy, and it's US state, so this one specifically here. So save. I think they actually had that in the, oh, it froze again. I do not know what's going on with code today. We'll just have to wait for a second. We'll continue on here. If we were to call value in cents, pass in coin, quarter, US date, Alaska, coin would be coin, quarter, US date, Alaska. When we compare that value with each of the match arms, none of them match until we reach coin, quarter, state. At that point, the binding for state will be the value US date, Alaska. So state will be the enum that is currently set to the value of Alaska. We can then use that binding in the print line expression, thus getting the inner state value out of the coin enum variant for quarter. So yeah, that's why we needed to not forget this in the US state. Not for coin, just US state. Aha, I'm ready. Waiting. You can do it. Okay, so yeah, my coin is worth 1 cent, my coin is worth 5 cents. You got state Colorado. My coin is worth 25 cents. So yeah, so that's a way of sort of like extracting this in here. And so I assumed that I could also do a match right in here if I really wanted to. Or like send that to another function that would match and return it. So that's actually sort of like a nice way of doing things. It recovered faster this time, but still a little bit weird that it's failing like that. Where were we? Oh, and last little mini section. If we were to call, oh no, we got this. We did it all. So our next section is going to be this. We're not going to cover that today because it is 7:59. It's about time for me to just close and reopen VS Code. Yeah, that's probably what it is. It's still a bit annoying. Let's try that. I'm gonna. Alt F4. We're in learning code. Let's open up code here and see if this is working. We're now at 6.2, I believe. Yep, 6.2, matching with. Matching with option T. Okay, so save that. We have our sort of plan for the end of the chapter, rewriting Fahrenheit to Celsius converter, and then everything should be good there. Anyways, thank you, Felix, and anybody else who's watching for stopping by and watching me learn Rust. I do these streams every single morning at 7 a.m. If you've enjoyed this and you want to sort of like keep on watching, please follow or subscribe to the channel. This month has been an experiment with YouTube streaming. Previously, I had streamed over on Twitch with some programming stuff, and I'm trying to decide, do I want to stay here or do I want to move back to Twitch to finish it out next week? So if I have a link to my Twitter in the description for this video and all the videos I've been coming out with. Please follow me on Twitter and wait for a later this week. I'm going to put a poll out for which one I should continue with, and I'll also mention it on the stream when I do that, so that way you guys can vote and determine where I'm going to go. With that, I'm going to move on with the rest of my day. Before I forget, I am going to push these changes up, which is playing with enums and sending that on up. Anyways, thanks again for watching. I'm hoping that this is providing some kind of value. And I'll see you guys tomorrow morning. Have a great day, or for those of you watching the VOD or in Europe, have a great rest of your day. And click.